Hello everyone, welcome to my channel. So today we will discuss and solve another most frequently asked coding interview question. So let's get started. Let's understand the question first. Suppose you are given a linked list with values in this particular sequence 7, 47, 13, 38 and then null. Now you have to reverse this linked list as 38, 13, 47, then null. So here three kind of scenario can occur. One that I have already told you, which is given. Second is, it might possible that your linked list has only one value. In that case, even after reversal also, the output will be same as input. Like here, output is 38 turns to null, output is same. Also, the next scenario can be that your linked list is totally empty. There is nothing in it. So in that case, your input and output both will be null. Before jumping into the solution part, let us first understand what is a linked list. As you can see, that linked list is a linear data structure which consists of nodes where each node actually contains two parts. First is the data and second is the link or the reference to the next node. Let's understand with one example. The sequence that we have seen already in our question, right? 7, 47, 13 and then 38. If you see here the very first node, the data part consists of the 7 and the next part consists the reference of this 47 node address. Similar way, 47, this part is the data part. This is the data part. And this part contains the reference or link to the next node which contains 13. Similarly, the rest of the linked list formed. And the last node of the linked list, or if the linked list has only one node, then that particular linked list next part contains null. As I have already mentioned, that linked list is a linear data structure, right? Then what is the need of this next part when it is already a linear data structure like array? Array I have already explained previously, right? That array is also a linear data structure where data stores in a continuous memory location. Then if linked list is also a linear data structure, then why do we even use this next part for a linked list node? Let us understand it. So when we are talking about array, we have this imagination of those values which are in sequence 7, 47, 13, 38. They will be storing something like this, right? But this particular scenario is not true for linked list. When this four data are getting saved into a linked list or stored in a linked list, they are not getting stored in this way. They are not getting stored in a contiguous or continuous memory location. And that is why we need that next part, because 7 has to have the reference of the address for 47th node, that particular node which contains this value 47. And that way it will understand that while iterating after 7, which is the value. Similarly, after 47, 13 is the next value. So 47 node has to have that reference of that next node which contains this 13 value. Let us understand with one pictorial version. So imagine this as a memory. Okay. Now suppose 7 is this part, 7 is present in this place, 47 is present here, 13 is here and 38 is here. Now, if we put some index like this 0, 0, 0, 1, 0, 2, 0, 3. Now, accordingly, 7 is present in 0, 0, 0, 0, right? 47 is present in 0, 1, 0, 2. Whereas 13 is present in 0 to 0, 1 and 38 is in 0 to 0, 4. Okay. Now 7 doesn't know that where 47 is going or where 47 is present next. So that is why the next part of 7 will be containing the reference of this 0102 memory address. Okay. So that is how it will know that yes, next element is 47. Similarly, 47's next part will be containing this 0201's memories reference. And that's how it will know that yes, 13 is the next one. And similar for 13 as well. Here, one more point to mention, that Java actually uses reference for this next part. Okay. Whereas if you use this linked list in case of C or C++, like in case of C, they uses pointer, which actually contains the memory address in the next part. Means when we are saying this next part is actually containing the memory address, an integer value, which is nothing but 47's memory address, which is this one. But in case of Java, this is nothing like that. It contains the reference to the next node. Because Java don't allow us any control over reference or any memory location. And that is why Java does not have any pointer concept. There is also another theory that this reference is also a underlying pointer only. This reference is nothing but an underlying pointer only. But as Java doesn't allow us any control over this reference or memory location, so that is why we are not even allowed to do, or it will be giving you some exception if you perform any arithmetic operation on this reference variable. Whereas in case of C, if you perform any arithmetic operation on pointer, it will be giving you a particular integer value in that case, because it actually stores that memory location. So basically, linked list is a dynamic data structure because it can grow or shrink during the program execution according to our requirement. Whereas you have to fix the size of the array beforehand only. It cannot dynamically grow or shrink. So that is why linked list is much more preferable rather than array if any random access is not required in your case. So to create one linked list, first thing we will be taking two pointers, start and end. Both of them first will be pointing to null. Now the very first element is 7. So with start we will be pointing to 7 first. Okay. Currently in our new linked list we don't have any other element except 7. So that is why start and end both will be pointing to 7 only. Okay. Why have I written that end equals to start? Because start is only pointing to 7. And this particular scenario is applicable when you have only one element, or while inserting an element in your linked list, you don't have anything in your linked list. Your start and end both are pointing to null, and that is when you are trying to insert one particular value in your linked list, and that is why start and end both are pointing to the same value. So our first linked list become this. Okay. So start and end both are pointing to 7 only. Now let us come to the second part. Now what happened? What we need to do is we need to insert 47 after 7. So what will we do? We will be inserting after end. Why? I'll explain in a minute. So here first we know that start equals to 7. It was already there. But now end dot next we will be putting 47 because end was 7 till now. So if we want to insert 47 after 7, and that is why we have stored 47 in end dot next. And now what we will be doing is we will be pointing end to 47. So now here we have S and our end is pointing to 47. So what is the algorithm that we are following here? First, if your linked list is empty, there is nothing in your linked list, then point the start and end both of the pointer to that single element or the first element that you are going to add in your linked list. And the second point is, if there is element in your linked list, then first with that new values node, point that new values node in the end next part, means whatever value you have till now in your linked list. Now suppose you have this 747. What was the next value? Next value was 13. So what we will do is to insert it in our linked list, first we will be pointing to 13 using end next part. So end next part is pointing to 13's this new node's memory address, and then after that we will be pointing this newly added node 13 using end pointer. So this is the algorithm that we are following, and in this way one after another we are adding into this linked list. Similarly for the last value 38, again we will be pointing end next, means 13's next part will be pointing to this 38, then after adding it we will be pointing end as 38's node, and that is why S will be pointing to 7, means start will be at 7, and at the end of the iteration and adding E will be at 38. And that's how we will be achieving this linked list. Now let us understand the code once. So this is the code. I have already explained that why we have taken this node start, node end as 2 pointers, and this is the part which I have explained, that when you have nothing we will be pointing the new node with start and end both, and then when we have some value we will be inserting in this way from the end. Here is one more point to remember, that I have taken insert from end. Even you can insert from starting as well. Okay, now here to print that out, or rather to iterate the linked list to print it out, this is the method where first we will be checking with the size. If the size is 0, then there is nothing. If there is only one value, means we have only start, the very starts next is null, then in that case we will be printing only that one, else it will be iterating it over. Okay. Here one more very important point to understand. We have talked about node, right? I mean the next part that we talked about. So if we see this data and next, node is consist of these two parts. So programmatically when we explain it, it will be somewhere like int data. Why it is int data? Because I have taken the data as an integer. 17, 7, 37, all those are integer, right? So if you want to store any character or anything else, so accordingly you have to choose the data type of your data. And the next part is nothing but that is also a node, right? Because 7 is storing 7's next part is storing the reference of the memory address for 47. So this is actually is the node for the next node. Okay, so next we will be considering as a node. Okay, and then we have some parameterized constructor of this node class. Constructor I have already discussed before in my previous video. Go check that out. I'll be giving links in the description below. And we have some getter setter, so that we can set the value, we can get the value, we can set the next node and get the same. Now let us run it. One more thing, see here I have inserted 7, 47, 13, 38 using that insert method. Okay, this insert method. Now let us run it. See, we have 7, 47, 13, 38 and null. Here one more point to just remind you that this null will not be printed. Okay, I have actually to make you to make this output much more readable and understandable, what I have done is, after it completes the whole iteration to print everything, I have printing a null along with this arrow. Okay, so that is all, that how you can create a linked list, or rather single linked list using code. Now let us reverse this programmatically and understand that code as well. So to reverse our linked list, first of all we'll be taking 3 pointers: priv, next, cur. Cur means current, short form I have taken it as cur. Okay, so in the very first place, priv will be pointing to null, next will be pointing to null, but cur will be pointing to the very first node of your linked list which you want to reverse. So in our case, first node is 7. So at the very first point, cur will be pointing to 7, and that is why this. Now let us understand how we will use this in our algorithm to reverse the linked list. So first what we'll do is, first we will store this current node's next value in the next pointer. What is our current node? 7. What is the next value of it? 47. So first we will be storing 47 here in next. Okay, then the second point, after storing this, we will be storing our previous node to the current next node. What is previous right now? Previous is null. What is current? 7. So we will be storing previous, or rather right now null, after 7. So this is the line actually where you are reversing the linked list. Because here when you are writing 7-null, this is actually segregated 7 from this whole linked list, and it divided these two linked lists separately. One is 47 to 13 to 38, another one is 7 to null. Okay, what is the third part? After doing this two line, first we will be storing our current node in previous node. Means 7 will be pointing to previous, will be pointing to our 7 right now. So somewhere it will be like this. This will be previous. Okay, because this we have already segregated. Okay, so this is now previous, but and with the current node, now C will be pointing to the next node. What is next? Next is 47. So current will also be pointing to 47. So C for current and N for next, both will be pointing to 47. And I mean, following the same iteration or following the same algorithm again and again, it will be actually reversing the linked list. let us understand it. Sorry, this one will be null here. Yeah, now it's fine. Because as I have already mentioned that this will be segregated. So now let's go further. Now what will happen? Again the same algorithm in a loop, right? So now you have current as 47. First we will be pointing current's next node 13 in the next pointer. So this will be 13. Okay, so now "13" has been pointed by n. Okay, so the first line is over. Then according to the second line, we will be pointing previous node to the current next node, right? What is our previous node? 7. What is current? 47. We will be pointing previous node to the current next node. So here 47 will be, 7 will be the next node of 47, right? So somehow it will be like this. See, our next is 13 right now. 47 we taken up here from here, and we have added currents next. We have added our previous in our currents next. What was current? 47. What we have done? We have added previous post 47, and that's how we got this linked list. Meaning, as I have already mentioned, this line is doing the reversal. Then what we'll do? Two more steps. First, we'll be pointing our current node, which was 47, as previous this, and we'll be pointing the next node with our current node. So whichever is current node, that is only the next node. And the similar way it will be happening for 13 and 38 as well. Then 13, 47, 7, and 38 will be current on next node, and here 13 will be pointed by the previous one. Similarly, again 38 will be coming first, and then 38 will be pointing by the previous one, and rest of the part 13, 14, and that's how we achieve the reversal of this linked list. One more point to remember: after reversal, do not forget to point your first node of the reverse linked list with your start node or head node, whatever you take as the pointer, as the starting pointer of your linked list, because while traversing, otherwise it will be pointing to the very first one, which was 7. Okay, now let us go to the code. See, this is the same node that I have already explained in case of linked list creation. So that's what we will be using here. Then there is a similar insertion method that I am using to first create the linked list. And the algorithm I just explained you, that is nothing but this reverse method. We are doing the same thing using this reverse method. See, I have taken those 3 pointers: previous, current, next. Okay, and the print list method is a similar method which we will be using to iterate that linked list and print it out. Okay, so let us just run it once. See, first we have this linked list 7, 47, 13, 38. Then we have reversed it: 38, 13, 47, 7. Also, for 2 more scenarios that I have already talked about, if your linked list has only one value, what will be your output? See, your input and output both is same, which is 7 tends to null. Okay, and what if you have nothing in your linked list, empty linked list, you are not inserting anything, you are just trying to print without inserting anything? and reversing anything. See, null. And one more thing is, please do not get confused with this null. It is not getting printed automatically. I have just given it for more like visual understanding that yes, after that it will be pointing to null, as there is nothing. So that is why the null is getting printed. Okay. One more point to mention here, that the time complexity of this particular algorithm or the way that I have coded is big O of n, and the auxiliary space that it is taking is big O of 1, because here the number of elements, so depending on the number of elements, the number of iteration are there. So if the number of elements is n, so that is why the time complexity is also big O of n. That's all for today. If you like this video, please do like, share and subscribe to my channel. I'll be catching up with you guys in my next video. Till then, keep learning with Proy.